I welcome all of you to the class. As far as the today's class is concerned, today we will be discussing one more unit, our unit number 2 of the syllabus. And today the topic is the the solutions of system of linear equations. Okay, today we'll be talking about the solutions of system of linear equations. As far as the system of linear equations are concerned, you must have seen the solutions. You must have seen the system of linear equations when you must have been discussing your mechanical vibrations or coupled spring mass dashboard system vibrations, where you had the equations that were linear equations, and but in fact the linear equations were obtained by simplification of the what you call as the differential equations, okay, by using the Laplace equations or any other method. Now, as far as the today's topic is concerned, today we'll be talking about the solutions of system of linear equations. So, the topic is solution of the okay. So it is about solutions or solution of system of linear equations. Okay, as far as the linear equations are concerned, we have the general form of equations, like we have some coefficient a11 x1 plus a12 x2 plus a13 x3 plus so on, plus a1n xn is equal to b1. Okay. In the same way, we have one more, a21 x1 plus a22, that is, let me rewrite the equations, a11 x1 plus a12 x2 plus a13 x3 plus so on, plus a1n xn is equal b1. Similarly, we have a21 x1 plus a22 x2 plus a23 x3 plus so on, plus a2n xn is equal to b2. So these equations keep on, we have n number of such equations. Okay, so the nth equation will be a n1 x1 plus a n2 x2 plus a n3 x3 plus so on, plus ann xn is equal to bn. Okay, so we are having a system of linear equations. Linear because the variable x1 x2 x3, they have degree 1, okay, everywhere. So this is a system of linear equations, and we are asked to solve this system of linear equations. That is, we have to find the value of x1, we have to find the value of x2, we need the value of x3, so on. We need up to the value of xn, we need to find out x1 x2 x3, so on up to xn. So this is the lecture in which we'll be talking how to solve this system of linear equations. What is the method, or what are the methods by which we can solve the system of linear equations? Okay, as far as the first method is concerned that we'll be discussing, the first method that we will be discussing is what we call as the Jacob's method. Okay, so I will be starting with the same method. The first method, let's take up the first method for today for solving a system of linear equations. And the method that we have is called the Jacobi method. So first method for solving the system of linear equations is what we call as the Jacob's method or Jacobi method. Now, as far as the Jacobi method is concerned, how do we use this method is just a minute. Okay. The Jacobi method, we'll be using this method. Let me take up an example. We are having an equation. The question says solve. We have to solve 20x1 plus x2 minus twice x3 is equal 17. You have three variables, so we need three equations, and all the three equations are given to us. 3x1 plus 20x2 minus x3 is equal minus 18. Okay, and 2 times x1 minus 3 times x2 plus 20 times x3 is equal 25. Okay, we are having three equations. This is a system of linear equations and we are asked to solve it. Solve for x1, x2 and x3, and it says accurate to 4. This is very important. Accurate to 4 significant digits. Solve it up to 4 significant digits. Okay, up to 4 significant. We have to solve it up to 4 significant digits. How do we solve such a type of question, accurate to 4 significant digits? So first of all, what we do, we have to start with an initial approximation. I mean to say, what we have to do when it says accurate to 4 significant digits, I mean to say we have to find x1, x2 and x3. Fine. How we will do it? So first of all, we start with the initial approximation, or we start with the finding the value of x1, x2 and x3, or writing it in the form of equations. That is, first step that we have to perform is from equation 1 obtain the value of x1, from equation 2 obtain the value of x2, from equation 3 obtain the value of x3. That is, get the value of x1. From here you will get x1 is equal 1 by 20, 1 by 20, 17, 1 by 20, 17 minus x2 plus 2 times x3. Okay, this is x1. From here obtain the value of x2. Our x2 is equal 1 by 20. Okay, 1 by 20, x3 minus 3 times x1 minus 18. Okay, and here from this equation obtain the value of x3. The value of x3 is equal 1 by 20, 1 by 20, 3 times x2, 3 times x2 plus 25, plus 25 and minus 2x1, minus 2 times x1. Okay, so this is the first step that we'll be performing. So our step 1 is from the system of given equations. From equation number 1, write down the equation of x1. From equation 2, we'll write the equation of x2. From x3, from the third equation, we'll write the equation of x3. Okay, so once we have done this, once we have obtained x1, x2 and x3, now we will start our iterations. And how do we start our iterations is, so let me clean this all. So I will write now the equations in hand are x1 is equal, I will write 1 by 20, 1 by 20, 17 minus x2 plus 2 times x3, this is x1, x2 is equal 1 by 20, okay, x3 minus 3 times x1 minus 18, and x3 is equal 1 by 20, 3 times x2, 3 times x2, and plus 25 minus 2 times x1. Okay, this is the value of x1, x2, and x3 as we have previously obtained. Now start the approximation. We start our iterations as by making an initial guess. Okay, let us start with, let x1 is equal, x2 is equal, x3 is equal to 0. This is our initial approximation. You are free enough to give your initial approximation. You can say let x1, x2, x3 is equal to -1, -2, -5, -6, whatever you assume. Okay, no problem at all. So let me say x1, x2, x3 is equal 0. So I have iteration 1. See, now this is a simple process. So I will go to the iteration 1. When we go to the iteration 1, in iteration 1, first of all, obtain the value of x1. How? In x1, substitute the value of x2 to be equal to 0 and the value of x3 to be equal 0. Okay. So we'll obtain the value of x1 in iteration 1 as, in iteration 1, in equation for x1, put the value of x2 equal to 0, okay, and x3 equal to 0. So we'll obtain x1 is equal 17 by 20. Okay, 17 by 20, and that comes out equal to 0.85. Okay, this is 0.85. Okay, similarly, go to the equation 2, find the value of x2. When you find the value, when you are going to find the value of x2, in that very case, you have to put x1. Now what's very important is to play with the value of what is to substitute the value of uh, x1, put x1 equal to 0 and x3 equal 0 to obtain the value of x2. Are you getting me or not? So as you go, it will be minus 18 by 20. That's minus 18 by 20. Okay, that is minus 0.9. Okay, and obtain the value of x3 from equation third. So from equation third, as we have to find the value of x2, substitute x1 equal to 0 and x2 equal to 0. Okay, so it will be x3 will be equal 25 by 20. It will be 25 by 20, and that comes out equal 1.25. Okay, so this is the value of x3. So in iteration 1, we obtained the value of x1, we obtained the value of x2, and we obtained the value of x3. Now we'll go to the iteration 2. Okay, we'll go to the iteration 2. In iteration 2, iteration 2 is same as iteration 1 except for the approximations. See, in iteration 1, we said that x1, x2, and x3 are 0. But once you are going to the iteration 1, we have to say x1 is equal to 0.85. Okay, x2 is equal minus 0.9, and our x3 is equal, 1.25. Okay, our x3 is equal to 1.25. Okay, therefore go to the equation 1 again. Go to this equation to say x1 is equal, now you have x1 in terms of x2 and x3. Okay, so you have to substitute for, in order to find the next x1 in this equation for x1, you have to substitute the value of x2 and x3. Okay, that will be 1 by 20, 17 minus x2. X2 is minus 0.9, minus minus will be plus. It will be plus 0.9 and plus 2 times x3, that is 2 into 1.25, that is 2.50. Okay, so that will be equal, x1 will come out equal 1.02. 1.02. Okay, now find the value of x2. How do we find the value of x2? X2 will be finding with the help of equation 2. Okay, in equation 2, substitute the value of x3 equal to 1.25, substitute the value of x1 to be equal to 0.85, and obtain the value of x2. I will directly write here, that will be equal, x2 will be equal minus 0.965, and in the same way find the value of x3 from this equation 3 by saying that x2 is equal minus 0.9 and x1 is equal to 0.85, therefore obtain the value of x3, and that will be equal to 1.03. Okay, so now these values of x1, x2, and x3 will take you to the iteration 2. Oh, sorry, iteration 2 is here. Now we'll go to the iteration 3. Okay, let's move to the iteration 3. Okay, so in iteration 3 we will say our x1 is 1.02, x2 is minus 0.965, and x3 is 1.003. Okay, in iteration 3 again obtain the value of x1. Okay, using this value of x2 and this value of x3, substituting in equation 1. Okay, as you do it, you will get the value of x1 will be equal 1.0012. The value of x2 will be equal minus 1.0015, and the value of x3 will come out equal 1.0033. This is what happens after iteration 3. Okay, after iteration 3, what is happening after decimal? The two significant figures are common. Okay, but the question says we have to find it accurate to 4 significant figures. Okay, so what we'll do, we'll go to the iteration number 4. In iteration number 4, we will go with this value of x1, with this value of x2, and with this value of x3. So as we go to iteration number 4, in iteration 4, I will directly write the values because this is quite simple now. In iteration 4, the values of x1 will be 1.0004 will be the value of x1. The value of x2 will come out equal minus 1.0000, and the value of x3 will come out to be equal, in iteration 4, it will come out equal 0.9996. With these values of x1, x2, and x3, we'll begin our iteration 5. Then we'll go to our iteration 6. Okay, we'll go on. Okay, in iteration 5, you will find the value of x1 is equal to 1.0000. The value of x2 will come out equal minus 1.0000, and the value of x3 will come out equal 1.0000. With these values of x1, x2, and x3, start your iteration 6, and you will again find the value of x1 will be 1.0000, x2 will be minus 1.0000, and x3 will be 1.000 and you have to check it as we'll go for iteration 5 to iteration 6. Okay, what happens? All the four significant digits are now remaining constant. Okay, so we will stop our iteration at iteration 6 and we'll say x1 is equal to 1, x2 is equal to minus 1, and x3 is equal to 1 are the solutions. They are the solutions. Okay, this is how the Jacobi's method works. Okay, in the same way you can check, you can have some hands-on experience. You can do, if you solve this question, solve the question using Jacobi method. 10 times x1 plus x2 plus 2 times x3 is equal to 44. 2 times x1 plus 10 times x2 plus x3 is equal to 51. x1 plus 2 times x2 plus 10 times x3 is equal to 61. Solve this system of equation using Jacobi method, that is find the value of x1, x2, and x3. Correct up to 4 significant figures. Correct to 4 significant figures. This is to be solved in the same way as we solved the previous question using the Jacobi method.